Hello everyone, class 12th topic is oxidation of alcohol. Previous videos we have understood dehydration of alcohol. At a different temperature they were creating alkenes and ethers. Now it's a time to understand oxidation. As you know, oxidation means add of oxygen. Now let's check how different alcohols will produce different products on their oxidation. We will start first with 1 degree alcohol. The general formula of 1 degree alcohol, this one. OH is connected to the carbon, which is further directly connected to single carbon, single alkyl group. And this carbon hybridization will be sp3. Such type of alcohols are known as 1 degree alcohol or primary alcohol. On its oxidation, what it will produce, let me tell you a trick. As you know, oxidation means add of oxygen. So what to do? You have to increase bonding with oxygen every time. Like this carbon is making single bond with oxygen. So after oxidation, you just need to increase bonding with oxygen like this. And rest valencies you will satisfy with the help of hydrogen. We know carbon always make 4 bonds. Right now it is making 3. So fourth bond it will make with hydrogen. Oxygen valency we know 2. 2 covalent bond usually it is making it means its valency is satisfied, no need to add hydrogen there. That's it. Oxidation is done. Now please check which functional group we are getting after oxidation. This is aldehyde. Means after 1 degree alcohol, first oxidation we will get aldehyde. Okay, suppose we are oxidizing aldehyde further. Trick we know. This carbon is making 2 bonds with oxygen. Next time 3 bonds we have to make. But as we know, oxygen can't make 3 bonds, so we require another oxygen. I will write it like this. Now, the valency of this carbon is already satisfied. 1, 2, 3, 4. 4 valencies are satisfied. This oxygen is satisfied, 2 valencies. But this oxygen is making single bond. So its second valency will be satisfied by hydrogen. Now, if you will check it, you will find out it's another functional group which is generated over there, that is carboxylic acid. Means if you will oxidize aldehyde, we will get carboxylic acid. On further oxidation, third time oxidation, this carbon is making 3 bonds with oxygen. Next time we will make 4 bonds. And for all 4 bonds, 2 oxygens are required. This product will be generated. What is this? This is carbon dioxide gas. This carbon, whose oxidation is happening, finally will turns to carbon dioxide gas, and obviously it will break bond from R, means alkyl group, and this alkyl group will get separate oxidation. Different oxidizing products will be generated according to the nature of alkyl group, R group. Like how many carbons are there, according to that new products will be generated, and those products will be same like alcohol, aldehyde, carboxylic, and then again carbon dioxide. But I am talking about this carbon. So please check the pattern and the technique. 1 degree alcohol, single bond. After its first oxidation, double bond, and the functional group generated will be aldehyde. Oxidation of aldehyde, 3 bonds with oxygen, carboxylic acid, and finally to make 4 bond with oxygen, it have to convert itself into carbon dioxide, and this is the maximum stage of its oxidation. We know carbon can make maximum 4 bonds, so all the 4 bonds are with oxygen now. So this is the highest stage of oxidation of this carbon. Now let's check 2 degree alcohol. The general formula of 2 degree alcohol is this. OH is connected to that carbon which is directly connected with 2 carbons or 2 alkyl groups. This is 2 degree alcohol or secondary alcohol. Let's do its first oxidation. What is the technique? Here we have single bond. After oxidation, we just need to increase bonding with oxygen. That's it. We don't require any hydrogen because already valencies are satisfied. Carbon valencies, oxygen valencies, they are satisfied. Please check which functional group we got. Ketone. Means 2-degree alcohol on its first oxidation will create ketone. Now how ketonic oxidation will happen? Let's check. I need to write it separately to understand the concept. This is the general formula of ketone. Suppose this is bigger alkyl group and this is smaller alkyl group. And we are going to do oxidation of ketone. This is ketone. So obviously, to do its oxidation, either we have to break this bond or this bond because we want to connect this carbon with oxygen. So let me tell you which bond will break. Always you have to break bond from bigger alkyl group side. Like this. And this carbon will make connection with oxygen. Like this. Already it is making 2 bonds. Third bond it will make with oxygen. Now you can check this carbon, its valencies are satisfied. Only this oxygen valency is not satisfied. It is making a single bond. Second valency will be satisfied by hydrogen. So which functional group we got? Please check. Carboxylic acid. And the R group which is breaking, its first oxidation will happen, means you need to add its single bond with oxygen. And oxygen valency will be satisfied by hydrogen. Which functional group it is? Alcohol. In this fashion, we do ketonic oxidation. You have to break bond from bigger alkyl group. This rule is known as Popov rule. Note it down. We call it Popov rule. What that rule is saying? If you are doing oxidation of ketone, the bigger alkyl group will break bond from carbonyl carbon and further oxidation will happen. Its oxidation will happen separately. This we have done. And its oxidation will happen separately. First time oxidation will produce alcohol. After that, you know what will happen. If you are oxidizing it further, carbon dioxide gas will generate. If it is 1-degree alcohol, so on oxidation, right now we have done, it will create aldehyde. Further oxidation, carboxylic acid, then carbon dioxide and so on. So this is a way to do oxidation of ketone. Means 2-degree alcohol on oxidation firstly create ketone, then ketone will create carboxylic acid and alcohols on its oxidation. Now let's go for the 3-degree alcohol. This is the general formula of 3-degree alcohol. OH is connected to carbon, which is further directly connected with 3 carbons or 3 alkyl groups. This is 3-degree alcohol. First of all, let me tell you, direct oxidation of this 3-degree alcohol is not possible. For that, we require high temperature and strong acidic conditions. Means like concentrated acids we require here for its oxidation. With dilute acids or base or in neutral condition, 3-degree alcohol will not show any kind of oxidation. For that, high temperature and strong acidic conditions are required. In that condition, first it will show dehydration. Yes, first it will show the process of dehydration. Dehydration, how to do, we have already done. On dehydration, it will create alkene. This is OH and these are alkyl groups. Alpha carbons will be there. So alpha hydrogen and OH you have to release out, and between this carbon and this R you will make double bond. or this carbon or this according to stability of alkene. Already we have discussed all these things in previous video. Please check how to do dehydration. So the product generated after dehydration will be, suppose I am making double bond here, this alkenes, 3-degree alcohol firstly show dehydration in this condition and will create alkene. Now oxidation of this alkene will happen further. Please note down, direct oxidation of 3-degree alcohol will not happen. First it will create alkene by the process of dehydration, and alkene's oxidation will happen further. Now let's check how alkene will oxidize. Very simple. Look, in this video we are discussing only the trick to learn and to solve oxidation reactions. In next video we will understand mechanisms. Suppose this is alkene I have, and we are going to do its oxidation. Very easy. Just break your alkene from double bond like this. This carbon separately oxidize, this carbon separately oxidize. Suppose I am talking about this carbon. So you just need to add oxygen. Two bonds are breaking. So these two bonds will combine with oxygen. So this carbon will get oxidized. Same here. Like this. So right now the alkene which I am using, on its oxidation, you can check what I am getting. These are ketones. Ketone particles are generated. And suppose here if we have H. So obviously this carbon, this one, here we will have H. Which functional group it is? Aldehyde. So alkene can create ketone as well as aldehyde on its oxidation depending on nature of alkene. That's it. So 3-degree alcohol first on strong acidic condition will show dehydration process. Due to dehydration, firstly it will convert itself to alkene. Alkene on further oxidation can produce ketone and aldehyde depending on the nature of alkene. For example, like after dehydration, I got this alkene CH3, CH double bond, CH2. Its oxidation I need to perform. So just break it from double bond, and to understand it properly, let's draw these hydrogens here. Do its oxidation. This carbon when will oxidize, it will create this aldehyde, ethane 1-ol. And let's do oxidation of this carbon. This is also a aldehyde, methane 1-ol. So this alkene will produce both aldehydic functional groups, but the molecules are different. It is ethane 1-ol and it is methane 1-ol. Now to understand that concept, let's try some reactions. Starting with 1-degree alcohol. This is 1-degree alcohol. As you can check, OH connected to carbon, which is further directly connected with a single carbon. 1-degree alcohol. On its first oxidation, trick was increase bonding with oxygen. Let's increase it. Satisfy valencies with the help of hydrogen. This was ethane 1-ol. On its first oxidation will create ethane 1-ol. If we oxidize it further, right now 2 bonds with oxygen. Next time this carbon will make 3 bonds with oxygen. So obviously we require second oxygen, and valency of this oxygen we will satisfy with hydrogen. So ethane 1-oic acid, carboxylic acid it is. This one. And if we oxidize it further, this bond will break and this carbon will get its final oxidation, maximum oxidation up to carbon dioxide gas. So this is the pattern. Now 2-degree alcohol. Let's try with 2-degree alcohol. Suppose I have this alcohol. It's a 2-degree alcohol, OH connected to carbon, which is further directly connected with 2 carbons. Let's oxidize it. Increase bonding with oxygen. Single bond, next time double bond. That's it. Valencies are satisfied. Oxidation is done. It's a ketone. Now let's do ketonic oxidation. For that, I am going to write this compound separately. Can I write it like this? Now, let's do its oxidation. For oxidation of ketone, I already told you, we have to break carbon-carbon bond. And from which side we will break bond? From a bigger alkyl group side. This is bigger alkyl group. From here you need to break a bond. Which rule? Popov rule. So when bond will break, this carbon will show separate oxidizing product. Already it is making 2 bonds with oxygen. The third bond it will make with oxygen like this, and valency of oxygen will be satisfied by hydrogen. So which product is generated? Carboxylic acid, naming ethane 1-oic acid. And what about this carbon? This carbon will get its first oxidation. So CH3 as it is. This CH2 I am going to write, and this carbon will combine with single oxygen. And single oxygen valency will be satisfied by hydrogen. You can check alcoholic product is ethane 1-ol. Like this. So in this fashion, 2-degree alcohol's oxidation will be solved. 3-degree alcohol. Suppose I have 3-degree alcohol, this one. As I told you, direct oxidation will not happen. First, what will happen? Dehydration in strong acidic condition. Okay, dehydration. OH and alpha hydrogen will be removed. Now, which alpha hydrogen will be removed? This alpha hydrogen will be preferred because the alkene which is generated here will be stable alkene. To understand that concept better, please check previous videos. This alkene will generate. This one. Now let's oxidize it. To understand it, let's write it in a perfect way. This carbon connected with CH3 and one more CH3 here. This carbon I am writing here. This carbon have one hydrogen. Let's write one hydrogen connected with CH3 like this. So how to do its oxidation, alkene oxidation? You need to break from double bond. This carbon you will oxidize separately. This one. This carbon you will oxidize separately. That's it. Aldehyde functional group, ethane 1-ol, the name of the compound, ethane 1-ol. And here we are getting ketone. IUPAC naming will be propane 2-on or acetone, the common name of this compound. In this fashion, you need to do oxidations of different alcohol. Technique we have done in this video. Now one more last point, please note down. Carboxylic acid with one carbon atom means this one, which we call methane 1-oic acid. Common name formic acid. If it is generated at the end of oxidation, if this carboxylic acid is generated, so whether we have strong oxidizing agent or weak oxidizing agent, always it will oxidize itself up to carbon dioxide stage. This carbon will have complete its oxidation up to CO2. And what about these hydrogen? They will also get oxidation in the form of H2O. They will also be connected with oxygen water molecules. So please note down this point. Methanoic acid, if it is generated at the end of the oxidation, always you will oxidize it further up to CO2 and H2O, whether the oxidizing agent is strong or weak. Now in next video, we will understand which oxidizing agents are required for these oxidations. Thank you very much for watching the video.